Alright, we're going to talk about factors, multiples, divisibility rules, and prime and composite numbers. Factors are numbers that can divide other numbers. So here you can see all the factors of 18, and I'm going to do one for you, 24. I'm going to figure out the factors by making multiplication problems. I always start with the smallest numbers and just keep asking myself, does this work, and keep moving my way up. So 1 times 24, that works. 2, what does that multiply by? 12. How about 3? Does 3 times something work? Yeah, 3 times 8. How about 4? 4 times 6. How about 5? 5 doesn't work. Now I get to 6, so I know I'm done because I've already used 6. And I'm going to do a little alley-oop like this where I start with the number 1 and circle around until I have all of my numbers. 1, 2, 3, 4, 6, 8, 12, and 24. Pause the video and try these. These should be your answers. Alright, if we're talking about multiples, remember those are numbers that the number can multiply to become. So I just think of it as skip counting. So I'm just going to count by 4s. 4, 8, 12, 16, 20, 24, so on. Count by 10s. 10, 20, 30, 40, 50, 60. Okay, divisibility rules. These are shortcuts to know if you're able to divide by a certain number. So it's really helpful when we go on to simplifying fractions, which we are going to be doing pretty soon. So we want to know, can a number be divided by 1? Well, all numbers can be divided by 1, so all numbers are divisible by 1. That's the rule. Only even numbers can divide by 2, so those are numbers that end with a 0, a 2, a 4, a 6, or an 8. It doesn't matter how many digits are before it. If it ends with one of these, it's divisible by 2. 3 is kind of a trick. So 3, it says the sum of the digits are divisible by 3. What that means is I take my number, for example, 612, and I add up each piece or each digit, 6 plus 1 plus 2, and that's how I get 9. Since 9 can be divided by 3, then I know that 612 can also be divided by 3. For all even numbers that are divisible, that the last two digits are divisible by 4, the whole thing's divisible by 4. So we know it has to be even in order for it to be a multiple of 4. We're going to look just at these last two numbers. And since it is even, we're going to look into this. Is there something that can take 32 divided by 4 and I get a whole number answer? Absolutely. It's 8. So I know 432 could also be divided by 4. 5 is easy. If the number ends with a 0 or 5, we can divide by 5. 6 is kind of a trick as well. If both of the rules for 2 and 3 both work, then it's divisible by 6. 9 is the same exact trick that you had for number 3. The only difference is you have to see if the answer can divide by 9. So you're going to add up all the digits. If your answer can divide by 9, then you know that your number can be divided by 9. And the last one, if a number ends with a 0, then we know it can be divided by 10. Alright, so I'm going to do some examples for you. I'm just going to put a check mark in all the boxes that it works for. So I'm going to go through and go through each one of these and say which ones work. So, can they be divided by 1? Absolutely, all of them can. I don't even have it on there because it works for every single number. Even numbers can be divided by 2. I know that this number, and this number are all even numbers. The way I know is because they end with a 0, a 2, a 4, a 6, or an 8. Alright, here's where it gets a little tricky. The sum is divisible by 3, so I'm going to add this up. The first one is 6. That can be divided by 3. The second one, whoopsies. I get 22. That cannot be divided by 3. And then last one I get 12. That can be divided by 3. Are the last two digits divisible by 4? When it goes beyond 40, you might want to use a multiplication table or try long division, but 50 cannot be divided by 4. 68 can be divided by 4, and 24 can be divided by 4. 5 ends with a 0 or a 5. This one ends with a 0 or a 5. The other two don't. Divisible by both 2 and 3. Well, I'm just going to look in these columns. This one it works for. This one it works for. The other one it doesn't. The sum is divisible by 9. This cannot divide by 9. This cannot divide by 9. And that cannot divide by 9. And lastly, ends with a 0. That's the only one. Pause the video and try these. Alright, so I'm going to go through and show you my answers. This is the only even number. If I add these up, 2 plus 4 plus 6, I get 12. 1 plus 8 plus 7, I get 16. And 1 plus 2 plus 5, I get 8. Okay, so which ones are multiples of 3? Just this first one. Ends with a multiple of 4? None of them do. Ends with a 0 or 5? Just this one. Divisible by 2 and 3? Just this one. Multiple of 9? None of them are multiples of 9. And ends with a 0? None of them. Prime and composite numbers. Alright, I'm going to list the factors just as a review. 16 has 1, 2, 4, 8, and 16. 17 has just 1 and 17. 18 has 1, 2, 3, 6, 9, and 18. Okay, I want to know which ones are prime, which ones are composite, and which ones are neither numbers. Well, a prime number is a number that can only be divided by itself in 1. Or in other words, it has exactly 2 factors, not 1, not 3, just exactly 2. That would be 17. That is a prime number. A composite number has more than 2 factors. So notice all of these factors. These are both composite numbers. The only neither numbers are 0 and 1 because they don't have exactly 2 factors and they don't have more than 2 factors. Try these. Pause the video. Okay, you should have found that this one's prime. This is composite. Don't forget about 7 times 7. And this one's also composite. You have a NICU check to do tonight. Have a good day.